So let me record this. So room occupancy has two values. One, which is the number of people in a room, right? The number of people in this room occupancy class. Then there's total number, which is the total number of people in all rooms. Since this is shared, so that's the total number of people in all the room occupancy classes, right? So this is, and I tell you, since this is shared among all instances of the room occupancy, it's a static variable. Why is that grammatically incorrect? I gotta retype this and I'll re-upload that. Make it private too. And then you're gonna write 4 methods. Add one to room, so this will add add a person to the room, and it increases the total number of people in that room. Obviously, when that goes up, you should also increase the total number. So it adds a person to the room, so it increases the number in the room, and it also increases the total number of people. Remove one from the room does the opposite, but you make sure that you can't have any negative people in the room, right? So get number, that returns the number of people in the room, and get total, that's a static method. So you've got 3 instance methods and 1 static method. And this static method will return the total number of people, right? It's a static method because it works, because it's going to be returning a static variable, right? So next, this one is, I found to be the one that oddly enough people have the most trouble with. It is the complex number class, because complex numbers are hard because we make them hard, okay? Complex numbers aren't necessarily hard, but they are tricky. So, okay, they aren't hard, they are tricky, I will grant you that, and they do have a weird wonky equation that you'll have to look up, but they're not all that bad because the equations are pretty straight. Well, I can't memorize the equation, so I can't say they're straightforward, but it's easy enough to look up the equation on Wikipedia and translate it. So a complex number so a complex number is basically a point on a coordinate plane. You've got the real number coordinate plane, and then you've got the complex number coordinate plane. So a complex number is a number that's of the form a plus bi, where a and b are real numbers, but I is the square root of -1. All right? So here's the important thing, and I say this every single semester, and yet every time I get a student who doesn't listen to this, okay? You have only 2 fields for a complex number, a and b. You don't create a field for the imaginary number. There is no I. You don't create an int I in there as well to represent the imaginary number, because a and b are all that's matter. The I is implied. B is the number that's multiplied by I. So by having a b, you kind of understand what happens. So to add methods, complex numbers isn't so bad. So how do we add complex numbers? Well, we just simply add them together. So like if I have 4 plus 3i and 7 plus 2i, right? If I have a is equal to this, b is equal to this, then I want to add them together, a plus b. That's going to yield us 11 plus 5i, right? You're just going to add the real parts together and the imaginary parts together, right? That makes sense? So you would return a new complex number that is 11 plus 5i. For subtraction, same deal. Now multiplication is a bit trickier, okay? Because with multiplication, you're doing a times b, okay? Now a times b means that we are doing 4 plus 3i times 7 plus 2i, which means that we have to use FOIL, right? We have to use first, inner, outer, last to multiply this, okay? So we take 4 times 7 to get 28. So then inner, so we do 21i plus 8i, and now we do 3i times 2i, which is 6i squared, right? But what is I? What is I? What is the imaginary unit? I told you at the beginning. What is the imaginary unit? I's value is the square root of -1, right? Not your question. So this is the square root of -1 squared, right? Square root of -1 squared. So when you squared something that's the square root of something. So when you square squared root, what do you get? You get the thing inside the square root. It cancels. So this is times, so it's 6 times -1, which means that it's minus 6i. So the equation for this is that basically you have the real parts and you have the imaginary parts. So you've got, this value is, well, the real part value is the first parts, right? So let's call this so let's stop being confused with A's and B's. Let's turn this into X and Y. Now let's call this X dot A, X dot B, Y dot A, Y dot B, okay? So we've got X's dot A times Y dot A for the real part minus X dot B times Y dot B. Why minus as opposed to plus? Because when you multiply these two guys together, you get the -1. You get the I times I becomes -1, right? So actually, Wikipedia does a great job of giving you the equations, right? So, and you should look at those. And that's only for the real part. For the imaginary part, you got to figure out. You've got to do that yourself. But complex number, right? On Wikipedia, it's fairly straightforward. Right, here's the equation for multiplication, right? If you do a plus bi times c dot di, ac minus bd plus bc plus ad I. So this would be the new a. This would be the new resulting a. This would be the new resulting. So this would be the new resulting real part, the new resulting imaginary part. And remember, the I is kind of understood for your class. You don't need to include it. And then for division, it's a big complicated equation, but you can, but it's equal to this, where basically you've got the real part defined by this and the imaginary part defined by that. So just define the 4 operations you can do with that. Okay, so these first two exercises, this is worth 100 points. The first 2 exercises are only worth 12.5 points each. The last one is tic-tac-toe. So we're going to make a tic-tac-toe game. So we're going to create a game called tic-tac-toe to represent a game of tic-tac-toe. So it's a class. So we're going to so the state of the game, right, where everything is, we're going to use a 2D array, 3 rows and columns, right? 3 by 3. So the methods you will need for this, and you've got a lot of leeway on how you do this, is that you need to add a move, which marks either a square being X or O. We need a method that will display the current state of the board. We need a method to tell me whose turn it is. A method that will detect if there's a winner. This one's actually non-trivial. It's actually used, I've actually heard it used as like a warm-up question for like a phone screening question for some interviews for tech companies. It's not necessarily, it's not super easy but it's not super hard either. It's a good weed out question. Tell the user who the winner is if somebody won, right? And then restart the game. So then write a main method. You can write it in the class or somewhere else that will let 2 players play a game of tic-tac-toe, and you use the scanner in the main method and only in the main method, right? So that one's worth 75 points. All right. Now, when we get back on Thursday, I will. So on Thursday also, let's see. I will also be posting I'm going to be posting the practice exam in a bit, right? On Thursday, we'll go over the practice exam, and then I'm going to go ahead and we're going to work on our class a bit more. Why is this giving me an error here? One error found. Where is, oh, yeah, sorry, it didn't. And we're going to basically write we're going to do some basic, let's call it AI if we want to over glorify it for playing the game. So we'll write an AI for a dealer that's going to follow the rules of it. And that's really what a lot of AI is. It's just following a bunch of rules. It's a bunch of if statements essentially. And then we'll write a method that the dealer will use, and then we'll write a method that the player will use, and we'll see what that is, because the dealer follows a set number of rules based on what the player has, right? So, all right.